Road transport is responsible for nearly 25% of Europe's emissions, making it a critical sector in the transition to cleaner mobility. To scale up electric mobility, batteries must be designed for longer lifespans, modularity, and sustainability, accelerating electric vehicles adoption while ensuring efficient use of materials. Here is where MARBEL project steps in.
MARBEL main goals consist in the design, development, and demonstration of a next generation of lightweight and high-performance battery packs for electric vehicles. This involved different research and innovation actions in fields like materials, battery housing, thermal management systems, ultra-fast charging strategies, and battery management systems.
Running from January 2021 to March 2025, MARBEL brought together 16 partners from 8 countries to tackle the electric vehicle's battery challenges through a circular economy approach.
We applied a full LCA-based eco-design methodology. This methodology follows 4 simple steps that follow the scope of the Plan, Do, Study, Act. The 4 steps include the identification of hotspots and life cycle stages, followed by a strategy definition. Then we make sure that the strategies align with the technical viability, followed by the last step, which is the specific action definition.
By integrating up to 60% post-consumer recycled aluminum, MARBEL reduced carbon dioxide emissions and battery weight, extending the battery's life while lowering environmental impact.
We studied the effect of the high scrap content in the mechanical properties and macrostructures to aluminum alloys to extrusion process to produce the battery prototype.
We designed the MARBEL battery focused in the modularity and to reduce the number of components and parts. We used the same components for batteries of different sizes, also for the optimization of the battery life, and we designed the battery for the easy assembly and disassembly to improve the reparability but also the recyclability. And finally, also we improved the optimization of the battery with simulation tools to reduce the weight and size and to use the right material in the right place.
But material choices were just one part of the equation. A modular design approach was key to ensuring these benefits translated into real-world applications. This not only simplified assembly and disassembly but also allowed for scalability in production and easier second-life adaptation. MARBEL also introduced key innovations in the battery domain by putting in place a switchable battery junction box, designed to enhance compatibility and fast charging capabilities across different electric vehicle platforms. Other current challenges were tackled with other innovations such as an electronic device allowing to monitor cells individually, optimizing battery lifespan and performance. Complementarily, an AI-driven monitoring system has been put in place to predict potential failures, reducing maintenance costs and increasing reliability. To ensure safety, reliability, and industry compliance, MARBEL batteries underwent rigorous mechanical, electrical, cybersecurity and thermal testing and simulation to ensure safety and durability.
We have developed a characterization plan to evaluate performance and safety parameters at 2 different levels, at cell and module level. Performance tests have consisted on evaluating parameters such as open circuit voltage, capacity, internal resistance, and the aging of the cell, considering different conditions as different C rates and temperatures. The safety test consists of implementing tests in accordance with relevant standards, as well as specific test protocols to evaluate boundaries where thermal runaway occur.
We have simulated numerically the thermal behavior of the interior of an electrochemical cell to evaluate the temperature increase associated with the different charging and discharging processes. This helped identify the areas with the greatest heat generation and how the heat distribution is affected by the operating regime, which allowed the optimization of the battery thermal management system.
The project also incorporated electric vehicle-in-the-loop testing. This testing concept allows all battery components to be tested under real operating conditions in a versatile and flexible environment. Materials used in batteries were recovered through advanced techniques. closing the loop toward a truly circular battery value chain. Environmental assessments applying different methodologies such as a life cycle analysis have been performed for proving the innovation advances in the state-of-the-art.
We performed a comparative LCA between the baseline and the MARBEL solution. Results showed substantial reductions, especially in carbon footprint. There was a reduction of 33%. Also, in abiotic depletion, there was a reduction of 50%. Such improvements directly support the European priorities such as the European Green Deal, the Circular Economy Action Plan, the Eco Designs for Sustainable Products Regulation, and the EU Battery Regulation.
MARBEL breakthroughs in battery lifespan, modularity, and sustainability align directly with EU policy objectives. The project has set new benchmarks for the future of electric mobility. MARBEL, optimizing electric vehicles' battery systems performance.